Okay, here is the solution to question number 2 on web homework number 3. So we have a soccer player kicking a ball from a distance of 30 meters towards the goal. We want to find the initial speed of the ball if it just passes over the goal, which has a height of 2.4 meters. And we're given the initial direction of 40 degrees above the horizontal. So I've drawn a picture here. Notice the axes, X and Y. I've drawn a very crude goal posts or a net, soccer net. It's at 30 meters away from where the object is initially at the origin, and I have it reaching its maximum height just at the goal. And that's going to give us the minimum velocity we need to make this problem work. Okay, we need to write down a few things which were given. Oh, I guess one thing I should note is what's happening at various time intervals. So initially, t equals 0, or t naught, we're at the origin, and our final time is when the ball is just at its maximum point above the net. Alright, so let's write down what we know. So we're given at t equals 0, we know x naught is equal to y naught, which is equal to 0. Our ball starts at the origin. Now, at tf, our ball is at some final x position, which we know to be 30 meters, and the y position is 2.4 meters. We don't know what tf is, so that might be something we're going to need to find. We also know we have acceleration. Our acceleration is only in the y direction, because this is a projectile motion problem, and it's negative 9.81 meters per second squared. So what do we want? We want v x naught and v y naught, our initial speeds in the x and y direction. Okay, so I guess the first thing we can do is that we know, there's one thing also that we know that I forgot to write down. We know our final y speed, it's 0 meters per second. At its maximum height, our object at this point is not going to be moving up or down. It's going to have a vertical speed of 0. And we're going to use that fact right now. So at our final time, Vy final is 0, and we have the following kinematics equation. V final squared is equal to V initial squared plus 2 times our acceleration times our displacement in the y direction. So the final velocity in the y direction was 0. Our initial is what we want, so that's our Vy naught squared plus 2. Our acceleration is the acceleration due to gravity, meters per second squared, and our change in y, well, we go from 0 to 2.4 meters, so it's 2.4 meters. Okay, this gives us a initial y velocity of square root of 2 times negative 9.81 meters per second squared times 2.4 meters. And that gives you, if you plug that in your calculator, 6.86 meters per second. So we found our initial y velocity. We can now actually find the time it takes to reach that point, to reach that maximum height. We know also that our final y velocity is equal to our initial, it's not initial, it's final here. is equal to our initial y velocity plus our acceleration times delta t. Now delta t is t final minus t initial, and t initial is 0. So delta t is just our final time. Our initial velocity we just calculated, and our final velocity is 0. So we have 0 is equal to 6.86 meters per second minus 9.81 meters per second squared times t final. Now all that's left is to solve for t final, and I've already done that. I found t final to be 0.699 seconds. Okay, let's just highlight a few of the things we've found. We found the initial y velocity. We found the time it takes to reach the goal. And now all that's left is to figure out our initial x velocity, or the velocity in the x direction, and we know that in the x direction we have motion with constant velocity. We have no acceleration. Our acceleration is only in the y direction. So in the x direction we have delta x is equal to vx naught times our final time. Now, because our x displacement is 30 meters, and our time we just calculated to be 0.699 seconds, and that gives us, if we solve for v x naught, a speed of 42.9 meters per second. Okay, so we can actually go ahead and write down our initial velocity. Our initial velocity in component form is 42.9 meters per second in the x direction plus 6.86 meters per second in the y direction. And there's our answer.